Bismillahir-Rahman Rahim. Assalamu alaikum, dear students. Hope you all doing well. Dear students, this lecture is for grade 8, subject chemistry. And in this lecture, we will continue the exercise of chapter number 3. This is my 22nd lecture, and I am your lecturer, Mrs. Saira Jamal. In this lecture, we will do the extended question answers. The first question is, arrange the elements in each of the following groups in order of increasing ionization energy. We have to arrange the elements in the given group on the basis of increasing ionization energy. So the first element is lithium, sodium, and then potassium. So lithium, sodium, and potassium belongs to same group. As you can see, lithium, sodium, and potassium belongs to group number 1A of the periodic table, and they are called alkali metals. Now, as you remember, I told you that when we move from top to bottom along the group, ionization energy decreases. Ionization energy decreases from top to bottom. So why ionization energy decreases from top to bottom? The reason is this is because the shielding effect in atoms increases. Greater shielding effect results in a weaker attraction of the nucleus for the valence electrons, so they are easier to remove. This leads to decrease in ionization energy from top to bottom in a group. I told you that due to the addition of new shells, the shielding effect increases from top to bottom. So when shielding effect increases, what happened? The attraction of the nucleus on the valence electron decreases, and it will be easy to remove an electron from the outermost shell of the isolated gaseous atom. That's why ionization energy decreases from top to bottom. It means that potassium has the least ionization energy, sodium has greater ionization energy than potassium, and then the greatest ionization energy in group number 1 is of lithium. So as we have to arrange the elements on the basis of increasing ionization energy, so lithium has highest or greatest ionization energy, then sodium has greater ionization energy than potassium, and potassium has the least ionization energy value. Second case is chlorine, bromine, and iodine. All these elements belongs to group number 7A of the periodic table, and same like group number 1A, ionization energy decreases from top to bottom. So the least ionization energy will be of iodine, then bromine, and then the greatest ionization energy is of chlorine. So chlorine has the highest ionization energy, then bromine has greater ionization energy than iodine, and iodine has the lowest ionization energy. Question number 4. Arrange the elements in each of the following in order of decreasing shielding effect. The first case is lithium, sodium, and potassium. Second is chlorine, bromine, and iodine. And the third case is only chlorine and bromine. So as I told you before that the shielding effect increases from top to bottom along the group. Shielding effect increases from top to bottom along the group. So the lithium is present and in period number 2, and sodium in period number 3, and potassium in period number 4. So period number 4 element has more shell, it will have more shielding effect. Potassium has greater shielding effect because it has 4 shell, then sodium 3 shell, and lithium 2 shells. In case of the halogens, iodine, bromine, and chlorine, so chlorine is present in the third shell. So third period it has 3 shell, then 4 shell, and iodine has 5 shell. So 5 shell 1 has a greater shielding effect than 4, and 4 has greater shielding effect than the third one. So, and in this case same like bromine and chlorine. So bromine, in case of bromine and chlorine, bromine has more shells than chlorine. So bromine has greater shielding effect than chlorine. Shielding effect increases from top to bottom along group. Why? What is the reason? As we move from top to bottom along group, the number of electronic shell increases, means addition of new shells takes place. So the number of electrons in the inner shell also increases. As a result, the shielding effect also increases. Question number 5. Specify which of the following elements you would expect to have greatest electron affinity: sulfur, phosphorus, and chlorine. So I told you that in periodic table the greatest electron affinity is of the group number 7 elements or halogen group. So out of these three elements, sulfur belongs to group number 6, phosphorus belongs to group number 5, and chlorine belongs to group number 7. So chlorine is present in group number 7, has greatest electron affinity, because as we move from left to right across a period, electron affinity generally increases. Why electron affinity generally increases from left to right along the period? This is due to increase in nuclear charge and decrease in atomic radius, which binds the extra electrons more tightly to the nucleus, but shielding effect remains constant in each period. Therefore, alkali metals have lowest and halogens have the highest electron affinities in each period. So just we have to keep this in your mind that group number 7 A elements have the greatest or highest electron affinities, and group number 1 A elements have the lowest electron affinity values. Question number 6. Electronic configuration of some elements are given below. Group the elements in pairs that would represent similar chemical properties. We have to make pairs of them. First one is 1s2 to s2. So you can see that the outermost shell is second and it has 2 electrons. So the 2 electron in the outermost shell means that it is present in group number 2. Now we have to see another element. This is the purple one. A and H both have 2 electrons in the S subshell or in the outermost shell. So the element A and element H, they belongs to same group, that is group number 2A of the periodic table, and as a result they have similar properties. Same atomic number, same valence electronic configuration, so same chemical property. A and H are a pair because they have similar chemical properties. Then you can see in this case 2 is 2, 2 p6, 2 is the outermost shell, and 6 plus 2, 8 electrons. So it belongs to group number 8. And 1s2 I told you is an exceptional case because it does not have 8 electrons but 2 electrons, but the shell is completely filled. So this is the property of group number 8, that the outermost shells are completely filled. That's why this 1s2, which is the atomic number or electronic configuration of helium, it belongs to group number 8A and show properties same like the group 8 element. So B and D are pairs. B and D are pairs. Then look at the number of electrons. 3 plus 2, 5 electrons are present in the outermost shell. In this case also 3 plus 2, 5 electrons are present in the outermost shell of E. So C and E belongs to similar group, that is group number 5, and as a result they have similar chemical properties. F has 1 electron in the outermost shell and G also has 1 electron in the outermost shell, so they have similar chemical properties. These pairs of group have same valence shell electron configuration, hence have same chemical properties. Question number 7. Arrange the elements in pairs and groups in question number 6. We have F, G, A, H, C, E, and D, B. These are some of the elements. and we have to arrange them in group and periods. As I told you, the pairs are like A and H are pair, means A and H belongs to group number 2. So we will keep A and H in group number 2A, and F and G, which have one electron in the outermost shell, in group number 1A, and C and E in group number 5A, and D and B in group number 8A. So the similar elements which has same chemical properties and same valence shell electronic configuration, we have to assign them a specific position in the periodic table, which we have done here. Question number 8. For normal elements, the number of valence electrons of an element is equal to the group number. Find the group number of the following elements. Aluminium, atomic number of aluminium is 13, mass number is 27. First of all, we will write its electronic configuration. So the valence shell electronic configuration is 3s2, 3p1. So 3 n value is 3, so it belongs to the third period, and electrons are 2 plus 1 equal to 3. 3 electrons are present in the outermost shell, so it belongs to group number 3a. Period number is 3, group number is also 3a. Sulfur, atomic number is 16, mass number 32, configuration, valence shell configuration is 3s2, 3p4. So n value is 3, means it belongs to period number 3, and total number of electrons are 2 plus 4 equal to 6. It means it has 6 electrons in the outermost shell, so it will be present in group number 6a of the periodic table. Potassium, atomic number 19, mass number 39, configuration. The valence shell electronic configuration is 4s1, n value is 4, so it belongs to fourth period, and one electron is present in the outermost shell, so it is present in group number 1a. Oxygen, atomic number 8, and mass number is 16, configuration. Valence shell electronic configuration is 2s2, 2p4, n value is 2, so it belongs to period number 2, and total number of electrons are 6, so it is present in group number 6a of the periodic table. Question number 9. Write the valence shell electronic configuration of the following groups: alkali metals, alkaline earth metals, halogens, and noble gases. Alkali metal, their valence shell electronic configuration, general configuration, like not for any specific element. This n value mean that it may be period number 1, 1s1, 2s1, 3, 4, 5, 6, 7, any period number. For alkaline earth metal, as they have one electron, they have two electrons in the outermost shell, and the period may be from 2 to 7. Same is for halogens, 5 plus 2 total 7 electrons, and n will mean any period. And for the noble gases, 6 plus 2 total 8 electrons, so they belongs to group number 8a, and the n value varies from period to period. Question number 10. Write electron dot symbols of an atom of the following elements: beryllium, potassium, nitrogen, and iodine. There are two ways. The first way is, as beryllium is present in group number 2, it has 2 electrons in the outermost shell. Those 2 electrons you will represent by just putting 2 dots on beryllium, one up and one down. Potassium has 1 electron in the outermost shell, we will put 1 dot. Nitrogen has 5 electrons, so we will put 5 dots, and iodine has 7 electrons in the outermost shell, so we can represent it symbolically by putting 7 dots on iodine: 2, 2, 4, 6, and 1, 7. Or you can also make as Bohr models, like the first shell has 2 electrons, and in case of beryllium, atomic number is 4. 2 electrons are present in the first shell and 2 in the last shell. For potassium, 2 electrons in the first shell, then 8 second, 8 third, and then 1 electron in the outermost shell. For nitrogen, 2 electrons in the first shell and The as it has atomic number 7, so 2 in the first and 5 electron in the outermost shell. And for iodine, this is iodine actually, and this is potassium. So for iodine, 7 electrons are present in the outermost shell. 2, 8, 18, and 7 electrons are present in the outermost shell. So you can represent it. This is the better way, dot symbol. This is much better, but you can represent it by this way also, or both ways. Write the valence shell electronic configuration of the atoms of the following elements. An element which is present in period number 3, so 3s3p, and fifth group, so 3 plus 2, 5 electrons. Period 2 and group 6, so 2, 2 and 6 electron, 2, 4. And because s cannot accommodate more than 2 electrons, p can accommodate till 6 electrons. So 2 electron, and the extra we will put in 2p, which is 4. Copy and complete the following: atomic number 11, 14, 22, and 12, then 23, 29, mass number, number of proton, because number of atomic number and number of protons and electrons are always same, so 11, 11, 11, 14, 14, 14, 22, 22, 22, and 12, 12. This is mistakenly mentioned 13, 12, 12, and 12. Okay, or I think this is 13, 13, 13, and 30. Yeah, 13. This is 13. So atomic number, number of protons and electrons are always same. Mass number is different, and from mass number and atomic number we can find out the number of neutrons. So 23 minus 11 is 12, 29 minus 14 is 15, 47 minus 22 is 25, and 27 minus 13 is minus 13 is 14. So these are the number of neutrons. By subtracting the atomic number from mass number, you can find out the number of neutrons in any element. Question number 13. Imagine if you are standing on the top of neon 20 nucleus, how many kind of subatomic particles you would see looking down into the nucleus, and those you would see looking out from the nucleus. Just imagine you are standing somewhere here. So what you can see inside the atom and outside the atom. Inside the atoms is a nucleus which contains protons and neutrons, while electrons revolve around the nucleus. So the subatomic particles into the nucleus are number of protons, which are 10, 10 number of protons, and neutrons we can find out by subtracting the atomic number from the mass number. So 20, a neon 20 means that atomic mass is 20. So 20 minus 10 equal to 10, number of neutrons are 10. While 10 electrons revolve around the nucleus. The electrons revolve around the nucleus, they are present outside the nucleus. So we will write 10 electrons revolve around the nucleus. Question number 14. Chlorine is a radioactive element used to disinfect swimming pool, to clean swimming pool, or to kill all the germs from the swimming pool. We use the radioactive chlorine. It is made up of two isotopes. Chlorine has two isotopes, chlorine 35 and chlorine 37. But because chlorine 35 is more than chlorine 37, means the percentage abundance of chlorine 35 is 75%, and that of chlorine 37 is only 25%. The atomic mass of chlorine is 35.5, which is closer to 35 than 37. While, as I told you, that this 35.5 is actually the average of 35 and 37, because there is no specific place for isotopes in the periodic table. They just take out the average of their atomic masses. So write electronic configuration of each isotope of chlorine. Also write symbol of these isotopes. Atomic number of chlorine is 17. So you know that as isotopes are defined as the atoms of an element which has same atomic number but different mass number. So all the isotopes, they have same atomic number, and definitely electronic configuration will be same too. So for chlorine 35 and chlorine 37, electronic configuration will be same. Symbol of chlorine 35 and 37 will be a little bit different. Atomic numbers are same, the mass number are different. Atomic number of chlorine 35 is 17 and 37 is 17. Mass number here is 35 and here is 37. So isotopes have same atomic number, so same electronic configuration, but only difference is number of neutrons and their mass number. Question number 15. In each block, group, and period in the periodic table, where would you place each of the following elements with the following electronic configuration? 1s2 to s1. 1s2 to s1 valence electronic configuration is 2s1. So number of electron in valence shell is 1, so it will be present in group number 1a, and period number n value is 2, so will be present in period number 2. This next one is 5 plus 2, 7. It means that this is period number 2 and group number 7. This element contains a total 7 electrons in the outermost shell, and group number is 7. So it means that the period number is 2 and group number is 7. Then last one is valence shell electronic configuration is 3s2. So 3 means n value is 3 means that it is present in third shell, and 2 electrons are present in the outermost shell, so it is present in group 2a of the periodic table. 1s2, although I told you there are 2 electrons, but it is an exceptional case because this is for helium. I mentioned here exceptional or exception because helium although has 2 electrons in the outermost shell, because it is same like the noble gases. Question number 16. How can we determine valence shell electronic configuration and position of an element in the periodic table? The valence shell electronic configuration of an element from the position of element in the periodic table. Period number of the element indicates the n value, and n value of the valence shell, whereas group number of the element indicate the number of electrons in the valence shell. So if the group number 1 means that this element has all the elements which are present in group number 1a has 1 electron in their outermost shell. 2 group number 2 has 2 electron, then 3, so on and so forth. So the group number indicate the number of valence electron, and the n value indicate the value of valence shell. Coming toward the think tank, question number 1. What type of elements have the high ionization energies, and what type of elements have the lowest ionization energy? The element present at the top and right side of the periodic table has highest ionization energy, means noble gases. Group number 8a elements have, because their outermost shell is completely filled, so therefore it is very difficult to remove an electron from their outermost shell. Whereas the elements at the bottom and left side of the periodic table, like group number 1a elements, they have greater shielding, greater size, so they have a greater shielding effect and lowest ionization energy. Alkali metals have lowest ionization energy, and group number 8a has the highest ionization energies. Question number 2. Two atoms have electronic configuration. One is 2, 2s2, 2p6, and one is 2, 2s2, 2p6, 3s1. Ionization energy of one is 20801 kilojoule per mole, and second one is 496 kilojoule per mole. Match each ionization energy with one of the given electronic configuration and give reason of your choice. Configuration is 1s2, 2s2, 2p6, so 6 plus 2, 8 electrons are present in the outermost shell of this element, and 6 plus 2, 8, and 8 plus 2, 10. 10 is the atomic number of neon. So this is the electronic configuration of neon, which belongs to group number 8a. And then 1s2, 2s2, 2p6, and 3s1, there are 11 electrons. 11 atomic number 11 is of the sodium. So we have to compare the ionization energy of neon and sodium. It is clear from values of ionization energy that neon has higher ionization energy as compared to sodium. This is because sodium has greater shielding effect than neon. As a result, attractive force of nucleus for the valence shell sodium atom increases. Therefore, electron can easily be removed from sodium atom by utilizing less amount of energy. Hence, ionization energy value of sodium is less. Use the second member of each group from group number 1a, 2a, and 7a to show that the number of valence electrons on an atom of the element is same as their group number. Second member of group 1A is lithium, and the valence electronic configuration of lithium is 2s1. Here valence electron of lithium is 1, therefore its group number is also 1A. Second member of group number 2 is magnesium. Valence electronic configuration of magnesium is 3s2, which shows that it has 2 electrons in the outermost shell and is present in group number 2A. Second member of group number 7A is chlorine. Valence electronic configuration of chlorine is 2s2, 2p5. So it means that it has 7 electrons in the outermost shell and therefore its group number is 7. Question number 4, letter A, B, C, D, E, F indicates elements in the following figure. You can see in this figure A, D, B, C, E, F. These are different elements. Which elements are in the same period? You can see A and B are in the same period, and D and E are in the same period. So A and B are in the third period, and D and F. This is not F. Mistakenly, I mentioned F. This is E. D and E are in the fourth period. So A and B and D and E are in the same period. Write valence shell electronic configuration of element D. Element D is present in 1, 2, 3, 4, 4 period and second group. So its valence shell electronic configuration will be what? 4s2. Which elements are metals? We know that all the elements which are present in group number 1A and 2A are called metal. They are 1A are called alkali metal and 2A are called alkaline earth metal. So A and D are the metals. Which element can lose 2 electrons? As group number 2 elements has 2 electrons in their outermost shell, so they can lose 2 electrons. So D is the element of group 2, so it can lose 2 electrons. In which group E is present? E is present in group number 1, 2, 3, 4, 5. Group number 5. E is present in group number 5. Which element is halogen? Which element is halogen? Group 7A elements are called halogen. So F is a present in group number 7. So F is halogen. This is not A. This is A is alkali metal. This is F. F is called halogen. Which element will form dipositive cation? Dipositive cation means the element when loses 2 electron will get a +2 charge. So definitely group number 2 A element will loses 2 electron and then in turn will get +2 charge. Right, electronic configuration of element E. E is arsenic, atomic number 33, and 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p3. Total are 33 electrons which are present in arsenic. Which two elements can form ionic bond? A is metal and F is non-metal. A is metal and F is halogen. So metal and non-metal can form ionic bond, especially with halogen. Metal can form ionic bond with halogen. Can element C form C2 molecules? C is present in 3, 4, 5, 6. Yeah, it can form because it is oxygen and oxygen can form O2 molecule. Which element can make covalent bond? B can make covalent bond because B is the non-metal and non-metals alone can be means non-metal like this is group number 4 carbon silicon. So silicon can make covalent bond by making bond with oxygen. Is element F a metal or non-metal? F is non-metal because all the elements that are present at the right sides they are non-metals. Question number 5, electronic configuration of 4 elements are given below. Which of these elements is alkali metal? Have 1 electron in their outermost shell, so A is alkali metal. And the alkaline earth metal has 2 electrons, so this D is alkaline earth metal. Halogen have 7 electrons, so 5 plus 2 7. And noble gases has 8 electrons in their outermost shell, so the 6 plus 2 8 will be the noble gases. Now we will write alkali metal 1s2, 2s1, 1 electron in the outermost shell. Alkaline earth metal has 2 electrons in the outermost shell. Noble gases is the helium, which is the exceptional case. It has 2 electrons, but the outermost shell is completely filled. And 5 plus 2, 7 are for the halogen. Last electron of last question of this chapter is, in what region of the periodic table you will find element with relatively high ionization energy and low ionization energy? I told you that the element present at the top right side of the periodic table, like noble gases, has highest ionization energy, while the elements which are present at the left side of the 1A group, the lower side, they have lowest ionization energy, especially group 1A element. So dear students, I hope you understand this lecture. This was all about the exercise of chapter number 3. Inshallah, in our next lecture, we will start next chapter, chapter number 4. Until that, take care. Allah Hafiz.